Hello and welcome to Numbers. Here we're going to go back and revisit what our numbering system is all about and why it's the coolest thing in the history of the world. We start back with numbers in Babylon. Now, Babylon had two symbols for numbers. Basically, it was one of these thingies and one of these thingies. And really, they started counting up 1, 2, 3, 4, 5, 6, 7, 8, 9 until they got to that and got 10. So, like the number 38 would have been 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. There we go. There's the number 38. Now, this was pretty cool. I want you to notice, first of all, what happened is they had two symbols. That's all. That's it. When you're learning your numbers, all you have is two of them. And then all you do is count them up. And that's it. That's how you work. This worked really well right up until the number 59. And they realized you start getting a whole bunch of these and you'll get a whole bunch of those. Pretty soon it's pretty hard to tell what number you actually have. You'll notice over here I'll write the number 38 under the current section and you'll see how nice that was. But we have to know all the symbols 0, 1, 2, 3 to even make sense of that number. Here they like 38 and that was great. Then they get up to the number 61 or 60 and this is how they did it. This represents 60 and then there's a space, and then there's a number one. This over here in the first space is how many 60s there were. And that may seem really weird. So if you did something like this, this is 10 60s, so that's 603. That's the number 603. If we had the number, let's write that down, that's 603. So you can see that. If you had, say, 1, 2 there, and then 1, 2 there, 1 there, 1 there, well, let's do that. This would be 21 60s. Holy cow, 21 60s and 22 ones. So this is like 1260 and this is 22. So this was the number 1282 right there. Holy cow. Now it was kind of neat. They started this and they realized that, hey, if you put something over here, it means something different than when you put it over here. Like these 10s actually meant 1060s. So they started the idea of place values. So something has a value of 600 over here, but it would only have a value of, say, 10 over here. So those are place values. That was kind of an interesting concept that you can put them in two different places. The problem was if they just did that, is that 60 with 0 ones or is that 1 with 0 60s? That's a good question. Now, at this moment, I need to stop you from thinking how weird they are. You're like, what? That's the weirdest thing to go up to 59 and then all of a sudden at 60 you have, you mark 1 there. Well, consider the last time you told time. You have 158, 159, and then 2 o'clock. And yes, the Babylonians are the ones that gave us that 60-second minute, 60-minute hour, and a 360-degree circle, by the way. So you ought to not think they're too weird. Now, so that's kind of some cool things. Here we got two symbols is what they had, and then they got this idea of place value. The Egyptians and Romans kind of did a very similar thing to each other. The Egyptians, instead of having this numbering system that got all like that, they had a little staff. 1, 2, 3, 4, 5, 6, 7, 8, 9. And as soon as you got 10 of them, a little heel bone like that. So this number, there we go, 1, 2, 3, 4, 5, 6, 7, 8. There we have the number 38 right there, just like this guy was 38, that guy was 38. And you're like, well, they're about the same. Now the difference is that instead of using a place value, the Egyptians, when you got 10 of these heel bones together, so you would count up 1, 2, 3, 99 like that, and as soon as you hit 100, you had a little cool little scroll like that, and that was 100. So the number, 603, you'd have 1, 2, 3, 4, 5, 6, 1, 2, 3. So you'd have 603. So what they did, instead of just using two symbols, they started using multiple symbols. And as soon as you got a bunch of those together, you started using a flower or a fish. You got 10 fish together, you started using these guys that are kneeling. Anyway, they started using a lot more symbols. every time they got another power of 10. And that was kind of an interesting idea. So they ended up with many symbols. But they didn't have really place value. They just added them up. But the symbols kept you from having to repeat the same thing over and over and over again. Now, if you remember the Romans, they did 1, 2, 3, and then 4, they did 1 away from 5, and then 1 away from 10 was 9, and then they did 10, and that was 50, and that's 100, and 500 and 1,000. And so they had letters that they could keep going, but can you keep going on forever? You'll run out of letters eventually. So you start stacking these up. So the Romans, again, had many, many symbols, and they started this idea as well that a 1 in front of an X and a 1 after an X, they're different numbers. Again, so looking at things that have a place have a certain value. So when we take these together and we see what our current system can do, it's pretty amazing. Because our numbers, we decided, hey, let's have only 10 symbols. That's it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We will never have to know any more symbols than this if we allow for place values. For example, this number 38 that we had before, normally 3 is smaller than 8. But because the 3 is where it is, we call this how many tens? So that's 38. That 3 is actually bigger than the 8 because the 3 is in a different place and has a different value. We can thank the Babylonians for that idea. So let's write out in each of these how they would do the number 438. So over here, 438, we first have to find out how many 60s that is, and that would be 7 of them. 1, 2, 3, 4, 5, 6, 7 60s, and that's 420, and then 18. So 1, 1, 2, 3, 4, 5, 6, 7, 8. Good. So this is 7 60s, 420, and a 10 and an 8 in space in this place here. The Egyptians for 438 would have written 400, 1, 2, 3, 4, 3 tens, and 8 ones. Good, 438. In Roman numerals, 400 was 100 less than 500. So CD, 400 and 38. So that's 3 X's, and then a 5, and then 3 ones. 438. And then the Arabic and Hindu way of doing things is that you can take 4, this symbol, and because of where it is, you can say, hey, this is in the hundreds, that's how many tens, and that's how many ones. And only use a limited number of symbols so you don't keep going on forever and ever, and use this idea of place value. And this is a stinking awesome setup. Think about this. If I write this out, 3, 2, 5, 6, 9, and what that actually means. It means that we have here 9 ones, 6 tens, 5 hundreds, 2 thousands, and then what's the next one up? Times by 10, 3 10,000s. The other cool thing about this numbering system that these guys didn't even have access to is being able to write partial things like decimals. Like if I did this, 0.583, wow, this is now getting into fractions. That's a tenth, and that guy is the hundredth, and that guy is the thousandth. We're running out of room here, so let's see if we can clear it up and write out a big number and look at all the place values. First, let's look at that number that we had, 32569. What this really means is we have 3 10,000s. That's a huge amount. But notice this 10,000 didn't come because of a new symbol. It's already there because of its place. And that 3 is much bigger than that 9 right now. Plus 2 thousands, plus 5 hundreds, plus 6 tens, plus 9 ones. Oh, look at that. That's nice. This right here, when you split it all out like that into what it really means down to the nitty-gritty level, that is called expanded notation. And we're going to come back to that. This actually is the fundamental of why we add by lining up decimals and other such things like that. So this is very important that you understand expanded notation is really what this thing means. And it's just an exploded diagram. Let's look at a really big number and see if we can look at it in expanded notation. Here's the number, 2,638,417.58934. All right, what is this now? Let's look at each of the place values here. If we were to write it out, this would be 2 in the, oh shoot. Let's go from this way. There's the ones place, the tens place, the hundreds place, the thousands place, the 10,000s, the 100,000s, and the, ooh, this is the millions place. Pretty soon you're looking at it like, well, all you did was put zeros there. That's exactly the whole point. Then this guy is the tenths place. Now that's kind of important to note. We don't have a oneths place. A oneth isn't a portion of anything if you cut something up into oneths. So it starts with the tenths, not with the oneths. And so this is the hundredths. For those of you that are familiar with finances, the word for hundredth would be cent. And yeah, so pennies, cents, that's why it ends in this column right here. This is thousandths, and then 10,000ths. And they're just exactly the same as those guys, getting bigger and bigger. Now they're with a TH on the end, and so they're smaller and smaller. And this one is the 100,000ths. So we're going to write this out in expanded notation, and it is huge. Holy cow. So we would have 200,000s. Nope, 2 millions. There we go. Plus 6. Yep, 600,000s, just like that. Then you get 3 10,000s. And so on. And you just match up the number with the place value to write it out in expanded notation. So when you get down to here, you're going to have, like, oh yeah, 5 tenths plus 8 hundredths. And so on, clear down to the bottom. Now the other thing that this allowed us to do was to use that number 0 very, very well. For example, the Babylonians didn't have a way to mark 0. The Egyptians didn't. Nobody needed to mark nothing. Why would you mark nothing? Well, one of the key principles of our system is that we need a location to tell us how big that number 2 is. And so if there are no 10,000s, we would mark it with a 0. That's very interesting that so many civilizations never used a symbol for 0, but we do. We have one. And yeah, if it said 0 10,000ths right there, then you would just either put 0 10,000ths there or not include it at all because there aren't any of them. So the 0 is actually fascinating. Now this leads us to rounding. Rounding is what we do when we don't want to read out the entire number. Let's go back to our number 32569. 32,569. Now the whole point of rounding is that you can say the word about. If you have exactly $321.57 in a savings account and you're talking to the bank, you're going to say something like, "Ooh, there's $321.57 in my account," or they will say your balance is $321.57. Now, if you're talking to your mom and she's worried about you making a car payment or a house payment or some sort of payment, and you say, "Mom, don't worry, I've got about 320 bucks in the bank." You're not wrong. You've just gotten pretty close and been able to say, "Hey, it's about 320 bucks." If you're talking to a friend that really you're not going to share a lot of financial information, she's like, "Hey, if you got enough to do that, hey, I've got over 300 bucks in the account." And so these about, you might actually get different abouts here. And that's what rounding is all about. We're just getting to the closest thing. And you'll notice right here, both of these are correct. This is about 320. It's about 300. It's not about 400. And that's what I want to show you here is if you have 300 and you have 400, like on this number line here, 300 right smack dab in the middle is 350. 321 is a little bit closer to 300 than to 400, and that's why we say about 300. If you're on the number line and you're saying, hey, and you're saying here's 320 and here's 330, 321.57 is about right here. So let's draw that right down there. So you would say about 320 if you're counting by tens, not 330 because it's closer here. Notice what the midpoint in would be 325. So if you're going to end at the tens is the most specific you're going to get, look at what that border is. Same thing here, 3 and 4, look at what that border is. It's a 5. As soon as you hit the 5, you're up closer to the 400, up closer to the 330. So right here, rounding, if you were told to take this number, 32,569, and round to the nearest 100. What this means is 32,569. If we were counting by hundreds, and we had this right here, we said, okay, so here's one, 32,500, and 32,600, and 32,700. We said, hey, which one of those is the closest? It's kind of nice. You can see where this guy is. He's somewhere in here, but is he more or less than these halfway marks? Notice this would be 32,550, 32,650. And yeah, you can tell because of this 6 right here, actually the whole 69, but that he's above that. That he's like 32,569. So he, if you're going to say to the nearest 100, is that guy. Because look at all that distance he would have to get down to there. So he's about 32,600. And so here's the rule. If you're going to round to the nearest 100, there's the nearest 100 right there, you actually take a sneak peek at the guy right before him. If this guy is more than 5, actually more than or equal to, I'm going to put a line under there, because 5 is right dead in the middle, and technically you could go either way. But as soon if there's any other numbers, then boom, you're over here. So we just make a rule, 5 or more, then you round up. So this 32,500 became 32,600. So this guy right here clicked up. And if you are less than 5, then that guy would stay exactly the same. Like that. And that is rounding. So let's try one more example and see what we get with it. So let's try one more example and see what we get with that. 2.7349. And let's say the instructions say round to the nearest hundredth. Hundredth with a TH on the end. So we look at the hundredths column. So we start counting tenths, hundredths. So this is the one we're looking at right here. So look at the next guy over. Is that less than a 5 or more than a 5? Well, that's a less than a 5. That's a 4. So we are under halfway. So you would round it to 2.73, and then these zeros at the end won't mean anything. Now there is something I would like to warn you about. Some people will try to round twice. They will look at this 9 and say, hey, that's more than half, so this should be a 5, which should round that up to a 4. Now let's look at it particularly. This 49 is less than a 50, and if you round up to the 50 to round up to something else, you've rounded twice and haven't actually gone to the nearest one. This number is indeed closer to 2.73 than 2.74. So rounding and then rounding again will lead you astray. Don't do that. Now this is what rounding can do for you. If I had something like 238 times 57, this is a kind of a complicated problem. Could take you a little while to do it. If you rounded, this is called estimation. You could estimate where the number would be. You could have 200 times 60. Holy cow, 2 times 6, that's 12. 200 times 60, 1, 2, 3 zeros. The number will be about, and we have no idea how close it is. I didn't actually do that problem, but it's about 12,000. So if you go through and do this problem and you get an answer like 439, you've done it wrong. This is a way of checking those answers. Estimation is when you round to the highest place value you can, round to the highest place value you can, and then do the easy problem. Round and do the easy. That is what estimation is all about. All right, good luck with that.